When you're writing an application that uses a database, sometimes it's a good idea to create a class that handles that particular schema. Let's take a look at an example of how you can do that in Python. We'll start by making a working copy of SQLite3 class.py, and we'll call it SQLite3-class-working.py. And we'll go ahead and open up that working copy. And here we have a complete working example of a class. It's very simple. It's just a few lines of code and how we access that class through this interface. We'll go ahead and run it, and you can see what it does. This is just an example of testing this particular class. So it creates a table test, and it creates some rows. It retrieves the rows. It tests these four functions of the database. So if we look at our interface, we create our object by passing it a file name and a table name, and that will actually initialize the database. And then we create the table using some SQL. Then we insert some rows using dictionary objects. Then we retrieve rows just using keys, and it'll retrieve dictionary objects. In our retrieve test, there's our dictionary objects. We update a couple of rows, again, using dictionary objects, and there they are. These dictionary objects could instead be specific classes that you've created for your database application. And we delete rows with keys. And you'll notice that every time we do one of these operations, we're printing out all of the rows in the database using the database handle itself as an iterator. So this is a nice little convenient interface. First of all, the constructor takes these two arguments as named arguments using the kwargs pattern. And the first one is the file name, and it assigns it to a file name property. And the second one is the table, and it assigns it to a table property. And you'll notice that these do not have underscores because these are meant to be accessible to the outside world. Down here, I use the property decorator to allow the file name to be assigned like that. And when it gets assigned, it actually connects to the database, and it sets up the row factory. And when you delete the file name, it actually closes the database. And so this allows you to use this kind of a pattern for assigning the file name, and you can even do this on the object level using the object. And it'll go ahead and initialize the database like that. Likewise with the table, it sets the table name, and that one is just really simply setting this underscore table variable. And if you delete it, it defaults to test so that there's always a table name, because it'll kind of break the code here if there isn't a table name, if the table name is blank, and you'll see that as we go through. So the insert function is very simple, and you'll notice it goes off the end of the screen here. So I'll just go ahead and reformat that. And so the SQL insert into, and you'll notice that we have to use a replacement in the string using format because the question mark pattern doesn't work for the table name. That's true across the board in every database engine I've ever used. If you want to use the positional parameters, you cannot do that for the table name. And so I allow the table name to be set using the format here, and it uses the underscore table. And then the row is passed in as a dictionary object, and here we make a tuple out of the two parameters that we're inserting, the values T1 and I1, and they're positional like that in order. So insert looks like that. Retrieve looks like this. It returns a dictionary object using the fetch1 method of the database cursor. And the SQL is just a simple select star from the table name. We're replacing the table name using format, and we're using positional arguments over here for the key. And again, this is a single element tuple, and so it has to have that comma, because the comma is what creates the tuple, not the parentheses. Update, it takes a row as a dictionary object, and it passes them in using a tuple. And the same pattern here, we're replacing the table name using the string format method. And delete uses a key, and there's the single element tuple there. And all of these methods that change the database, they all have this db commit. There's a display rows method that we're not actually using, which does what we were doing in our other examples. It simply prints them out using a print function. But here's how we're looking at the data in this example. We're using this iter method, and that's a special method in Python. If you put this in your class, it allows your object to be used as an iterator. So it has two underscores, underscore, underscore, iter __ for its name. And other than that, it works just like any method. And it's a generator because it uses yield, and this allows it to operate as an iterator. And so it simply yields a dictionary of the row, and that allows us to call it like this, for row in db print row, and we get these results. So we'll go ahead and we'll save this, and we'll run it again. And we see there we have our results. Finally, it's worth noting that because of this pattern down here at the bottom, if name equals main, then call main, this entire file will work just fine as a module in Python. You could simply say import SQLite class working, and you would have access to this class and be able to use this in another file. And this main function down here will be completely ignored because when you import it that way, this is no longer true. And so main will not be called. So it's a useful pattern to be able to write a module like this and to have a class that you're going to use throughout a project or even to distribute to the world, and to test it using a main function that is really just there for testing purposes. So this is a useful pattern, and it's one that you will probably use. Here we have a custom class for working with a specific database, and a lot of different techniques that you can use in building a class like that for yourself. It does the major 4 functions, and it does a couple of other things. The object itself is usable as an iterator because we included an iterator method. It uses properties for setting the file name that make it easy to change files if you want to. So here we have an example of how you can create a custom class for your own database schema for your own project, using Python's object-oriented features to make your programming task a lot easier.